Hello again. You are watching Chemistry in Action. Today's episode is on water in our environment and is the last of our series of lessons on this topic. If you remember, we first discussed air and the atmosphere around us. Next, we talked about the various aspects of soil and its role in the environment. What is in store for us today? In this lesson, we will discuss the water we find around us in rivers, lakes, and oceans, how we use it, how we dispose of it after use, and finally, the harm we do to this valuable resource when we pollute our natural water sources. So, stick around while we take the short break. Ninety-7% of the Earth's water is found in seas and oceans. Of the remaining 3%, 2% is locked up in ice caps and glaciers. We are left with 1% from which to draw our freshwater supply. Our country has many bodies of water. Inland, we have more than 400 major rivers, 58 lakes, and more than 100,000 hectares of freshwater swamps. All these are fed by the abundant rainfall we have in the Philippines. Rainwater is of distilled quality only at the moment of condensation. As it falls to the ground, it picks up impurities and thus loses its purity. It is well to realize that no water in nature is absolutely free of impurities. Surface waters contain a normal level of impurities that come from the atmosphere, minerals and organic matter from soil, and from living organisms. We already know that the highly polar nature of water makes it an excellent solvent for ionic and polar substances. Some polar molecules dissolve in water because of hydrogen bonding. Water reacts with other polar molecules when dissolving them. On the ground, water dissolves more substances as it flows to rivers and lakes and eventually to oceans and open seas. Seawater normally contains 3 to 3.5% by weight dissolved impurities, mostly inorganic substances. This water has had extensive contact with the ground. It is described as saline to distinguish it from water in rivers and lakes, which are referred to as fresh water. How does this water reach us for use in our homes and factories? In general, we obtain our water via two methods. Through wells, when we tap underground water sources called aquifers, or by pumping fresh water from lakes and damming of rivers for community use. This water is processed to make it potable. One of the responsibilities of government is to provide the community with potable water. The Metropolitan Water and Sewerage System at Balara, Quezon City does that for Metro Manila. To supply millions of cubic meters of water per day, the untreated water is taken from rivers and lakes and stored in dams to allow twigs and leaves to settle to the bottom. The water is then brought to sedimentation tanks and treated with calcium hydroxide and aluminum sulfate. The two chemicals react to form colloidal aluminum hydroxide. These adsorb the very fine suspended impurities and settle as flocks. The process is known as flocculation. The clarified supernatant water is next filtered through several layers of gravel and sand of varying sizes. Next, it is treated with chlorine. Chlorine kills pathogenic microorganisms and oxidizes organic impurities that could otherwise impart an unpleasant flavor to the water. Finally, the water is aerated to allow the excess chlorine to escape. This is the water Metro Manila gets. It is by no means chemically pure, but it is safe for human and animal consumption. Many urban areas where population density is high experience water shortages because of the high demand for it. Why this great demand? What is water used for? Everyone knows the answer to this, but let's make a systematic list. Water users are classified into three types: municipal, industrial, and agricultural. Municipal users, those in homes, offices, hospitals, and commercial establishments, use water for drinking, bathing, cooking, cleaning, and gardening. Chemical industries make a great demand on water. Water serves as a raw material or as a solvent in many manufacturing processes. Water is also used as either a cooling agent or a heat transfer agent in power generating plants. The agricultural sector makes the greatest demand on water resources. Large quantities of water are used for irrigation. Imagine the amount of water needed to irrigate the 3 million hectares of rice land in our country. The National Irrigation Administration provides various irrigation systems for about half of this. The rest depend on private initiatives or on a natural source of water, rain. So far, we've seen where our water comes from and how we put it to use. What happens to water after we have used it? In Metro Manila and other urban areas, a very small percentage of used or wastewater is disposed into septic tanks, where the waste products undergo partial natural decomposition. The greater percentage goes directly into the sewers or sewerage system. The wastewater eventually ends up in the seas or ocean. Some of it can end up in rivers and streams, and so finds its way back into our water supply. If the amounts of dissolved substances in the wastewater are within normal levels, they may be processed as the water flows along. Processing includes decomposition by chemical oxidation or by the action of bacteria. Water dilutes some of the wastes as it moves on. With the aid of sunlight and heat, some wastes are bleached. Some industries have built big wastewater treatment plants to clean up their wastewater before it is discharged into nearby rivers. Still, some studies show that the quality of our rivers and lakes are quickly deteriorating because of pollutants we have introduced into them.